follow your studies with the following disciplines. Fresh up every morning, attend school, say good morning to your teachers. Then come in the evening, log in to VSM Academy at 5 p.m., revision previous classes and today's lessons and stay for 1 hour, log out at 6 o'clock. I am Veerabhadra Demaya from VSM Academy. I am welcoming you to VSM Academy on behalf of my friends. This is Science Lessons today. Welcome to VSM Academy on behalf of Employees Association Village in rural Karnataka. Well friends, matter is made up of pure substance and impure substance. Pure substance are further divided into elements and compounds. What are elements? Elements in the purest state of matter is called element. Example, hydrogen, carbon, iron, etc. Compounds, water is a compound. Now, elements are further divided into metals, non-metals, metalloids, noble gases. So, we will study well in detail. Metals and non-metals. It is Karnataka Secondary Education Examination Board, Sslc class for 10th standard, chapter 3 from the textbook. Question number 1, revision exercise for the examination point of view. Give an example of a metal which is a liquid at room temperature, can be easily cut with a knife. For third one, is the best conductors of heat and electricity and is a poor conductor of heat. Coming to the metals and non-metals, friends, it is metals and non-metals are very important chapters. You know, metal that exists in liquid state at room temperature is mercury. Mercury is a special type of liquid metal, so it is easily traceable and recognizable. Metal that can easily be cut with a knife is soft metal, very soft metal. Then coming to the metal, the best conductor of heat is silver. Silver is the best conductor of heat and electricity. Metals that are poor conductors is lead, because lead is very poor conductor because of its low melting point. Question number 2. Explain the meanings of malleable and ductile. Generally, metals are having the nature of malleability and ductility. Malleability means that any metal can be beaten into thin sheets. That's called malleability. Coming to the ductility, long metals are ductile. That means they can be drawn into thin wires. You can see the copper wires, lead, this one, what is that, silver wires, etc. Why is sodium kept immersed in kerosene oil? Sodium is a highly reactive metal. It is a very soft metal. It is always kept in kerosene oil because it is highly reactive metal. If you contact with air, it reacts immediately with the oxygen of the air and water moisture. It catches fire. It is a violent reaction takes place. Therefore, it is explosion reaction takes place. Therefore, it is always kept under kerosene oil. And coming to the second question, write questions for the reactions equations. Iron system. Generally, the metals with a moderate to low reactivity very slowly with water. Iron undergoes reacts with water, gives rise to hydrogen, forming ferric oxide, oxides of iron. Calcium reacts with water slowly, gives calcium hydroxide and hydrogen along with heat. And potassium is a reactive metal. It reacts with water, gives potassium hydroxide and hydrogen. It is an exothermic reaction. Exothermic means heat is evolved to the surroundings. Write the electron dot structure of sodium, oxygen and magnesium. Then show the formation of sodium peroxide and magnesium oxide and transfer of electrons. What are the ions present in these compounds? You see, my dear friends, electronic configuration, electron means immediately you should think about the structure of atom. Atom consists of electrons, protons and neutrons. The protons and neutrons are packed together in the nucleus and the electrons are revolving around the nucleus of an atom, like that of the planets, how they are revolving around the sun. That is the analogy, a reference for your understanding. Coming to the sodium, sodium is having atoms sodium atoms consists of 11 electrons. That means 11 electrons and 11 protons. So therefore, the electronic configuration. What is electronic configuration? Electronic configuration is nothing but arrangement of electrons in a systematized manner. Arrangement of electrons in a systematic distribution of electrons is called electronic configuration. Therefore, sodium, 281. First, I would like to tell this electronic configuration means immediately you should think about the structure of atom. The electrons which are revolving around the nucleus are often, these electrons are revolving around the nucleus in such a way, in the different orbitals. That's called atomic orbitals. First electron, 1s orbital, 2s orbital, 3s orbital, 4s orbital, like this. This is the Abba principle. It's a big procedure is there. Anyway, examination point of view, I'm telling you, it is distribution of electrons in the sodium atom is 281. That is totally 11 electrons are distributed in such a way to first cell and second cell and the third cell. Outermost orbit contains only 1 electron. You see, then coming to the oxygen 2,6. Because why it is 2,6? Because the oxygen atom consists of only 8 electrons. These 8 electrons are arranged in such a way 2 and 6. Similarly, magnesium. This is called electron dot formula. Lewis structure, also known as Lewis dot diagrams. Then it is also called as electron dot structures. See here the formation of sodium chloride. Sodium is 11 already I told. Chlorine is 17 electrons. These 17 electrons are arranged in such a way that in a different order, that K, L, M, N, O, P orbitals, atomic orbitals, and hence suppose if it loses 1 electron, this is transfer of 1 electron, it gives sodium chloride. This sodium chloride is a compound. This is the electron dot structure is 2,8. Here in chlorine 2,8,8. This is the electron dot structure. So these are the different according to the arrangement of the periodic table. This is the first group of the periodic table. Only one electron in the outermost orbital. These are 2 dots are there. That means 2 electrons. 3 dots are there. 3 electrons, like that. Depending upon the number of electrons in the outermost orbital, decide the factor of the valency. You please see the table carefully. Now coming to the define the following mineral ore ganj. Mineral. What is a mineral? The naturally occurring compounds and elements are known as minerals. What is an ore? Minerals from which the metals can be extracted profitably are known as ores. What is the ganj? Ganj is nothing but the impurities present in an ore such as sand, rocks, etc. are known as ganj. You see here mineral can be, it is nature iron ore for example. This iron rock, iron ore is chalcopyrite, hematite, magnetites are the iron ores. This is one of them. So this is called ore. This is copper ore, chalcopyrite, copper ore, iron ore, hematite, magnetite. Then coming to this one, it is the crystals of cassiterite, commercially valuable mineral in a matrix called GANs. In this one, this is called GANs. GANs means it consists of so many mixtures of so many chemicals, sand, rocks, etc. Question number 2. Name 2 metals which are found in nature in the free state. Gold and platinum. Gold, you know that it occurs freely in nature. Platinum is also. Minerals can be found in like this. This is important. This already explains. This is copper ore, chalcopyrite. Veerbhadraya from BVSM Academy, a School of Arts and Science. A mission with a vision. Try to follow the lessons carefully. Study well.